So we have some more examples of the elimination method. Now this example 5 is a little different than example 4. In example 4 we did not have to multiply the two equations by anything in order for one of the variables for the y's. In that case they had um, the same coefficients but different signs. Well, we look here, the x's, they have a 4 and a 5. Well, they're not the same number, and they are different signs though, so that's good. The y's, 3 and 2, so they're neither the same number nor uh, are they different signs. They need to be different signs. So you know what? It may be easier to just work with x in this case. It doesn't really matter, but I'm going to multiply the top one. Let's see what would happen if we multiplied it by 5. We would get 20x, and see if I'm wanting to cancel the x's, so I'm just going to stop there for right now. And if I multiplied the bottom one by 4, I would get negative 20x, and see, when I add those they would cancel. And do you see what I did? The top equation had a coefficient of 4, and that's what I multiplied the bottom one by. The bottom equation had a coefficient of 5, and so that's what I multiplied the top one by. So let me finish out my multiplication to see if this works out. So 5 times 4 is 20, 5 times 3 is 15y, and 5 times 11 is 55. 4 times, already did that, 4 times 2 is 8y, and 4 times 5 is 60. So let's add these equations together. Of course, this cancels like I need it to. 15 and 8 give me 23y, and that's equal to 115. So now I can solve for y. This is great. So divide by 23, and 115 divided by 23 is 5. So let's write that part to our solution down here, and let's then find x. Well, I'm going to plug this 5 into one of the originals, so 4x plus 3y equals 11. Well, if y equals 5, then 4x plus 3 times 5 equals 11. Well, 4x, 3 times 5 is 15, equals 11. Subtract your 15, and you get negative 4 equals 4x. Divide by 4, and you get that x equals negative 1. And this coordinate represents where these two lines would cross at on the graph. In example 6, I'm looking at the x's and the y's, and again, it doesn't matter if you choose to decide if you choose to eliminate the x's or the y's. It's your choice. I just like to look and see what we have going for us. And x's, 2 and 1 are the coefficients, and they're not the same number. They are different signs though. That's good. And then the y's, 3 and 6, they are different numbers, but they're also different signs. I'm just gonna, it doesn't really matter, I'm gonna choose to eliminate y. So I need them to be the same number. Now I could, let's see, I could multiply the top one by 2 and see, if I multiplied it by 2, that would give me negative 6y, and when I add that negative 6y to this positive 6y, they would cancel. So let's see how this works out. Let me do it in a different color to help us out. 2x, I'm multiplying the 2 by the top, minus 6y equals 2. And then I'm just going to write the bottom one down. I don't think we need to multiply it by anything. And it looks like these y's are going to cancel. Okay, and again, there's no magic method. You just want to multiply one equation or both equations by something so that the variable you choose, that both of those variables have the same number and different signs, and now y does. They both are 6. One's negative, one's positive. So I think we're good to go as far as adding these together. And whoa, look at here. I didn't plan on this, but my x is canceled. But that's okay. We'll just keep going. And the y's cancel. But on the end, we don't have anything that cancels, so we just put 7. 0 plus 0 is 0. 0 equals 7. That's not true. So this would be no solution in this odd instance. When you have a false statement, 0 does not equal 7. We have a part B in example 6 with this new set of equations. We're going to look at the x's and y's and determine what we want to eliminate. And again, it doesn't really matter. I'm just going to go with x because it's the first thing that I see. And the top x, the coefficient is 2. The bottom one is 4. Let's see. There's many things I could do, but I think the easiest thing to do would be to multiply this one. If I multiplied the top equation by 2, I would get 4x. The bottom is positive 4x as well, so when I add them together, that gives me 8x. That's not what I want. I want 0. So make it negative. If you multiply it by negative 2 times positive 2 is negative 4x, and negative 4x plus 4x is 0. See, that's the same number in different signs. So let's complete this distribution here. So negative 6y equals negative 12. And now I'm just going to write that second equation down, and look at this. This looks weird. It's sort of similar, but they're different signs. But let me add them together. 0, that cancels, plus 0, that cancels, equals 0. 0 plus 0 is 0. 0 equals 0. I got another statement, but this statement is true. This is all real numbers. When I put this answer in the computer for all real numbers, sometimes it wants me to, do a multiple choice thing, and I select the correct choice, of course, but in this case it's going to say x, all real numbers, and it's going to say where x is this, and you have to type in y. So when you get 0 equals 0, or you get a true statement and it's all real numbers, what you have to do is take one of your equations. So let me do this in a different color so we can see. 2x plus 3y equals 6. And I'm going to solve it for y, and I'm going to put that answer right here. And I forgot my parenthesis to close off the coordinate. The reason I'm solving for y, it finishes off that coordinate. Since I solved this and did not get a coordinate where they cross at, this is what I put in for the solution. Now, again, it does not matter which equation you choose to solve for y, because these equations are essentially the same exact equation. If you graphed these two lines, they would be on top of each other. Okay, and that's what we call a consistent dependent solution. So let's solve for y. This is what I'm looking for. So I'm going to subtract 2x from both sides, and I get that 3y equals negative 2x plus 6. And then I divide by 3 and get that y equals negative 2x plus 6 over 3. And that's what I want to type right here. Negative 2x plus 6 divided by